In a previous chapter, we learned about transformations, reflections, translations, and rotations. Let's review the notation. Remember that a reflection was represented by a capital R, and then we said where it reflected across. So that may have been reflecting across the x-axis, reflecting across the y-axis, or we could have even said reflecting across a specific line. Translations were represented with a capital T, given by an x and y value that told us how far we were moving left and right or up and down. And rotations were given by a lowercase r with the number of degrees and then the point about which we were rotating. This is a good review as we move into 7.2, which is similarity transformations. Helena and Edwin were asked to apply a composition of transformations to ABCD. Is there a composition of transformations that maps ABCD to the second figure in each student's work? If so, what is it? When we look at Helena's, we look at the shape and we see that it really is the same shape. It just needs to be rotated 180 degrees, and then we would need to dilate it by 2 to make it twice as big. So with similarity transformations, we really can have the same shape but different sizes. When we look at Edwin's shapes, we actually determine that Edwin, so this was Helena, and Edwin, they're not the same shapes. For each student whose work shows a composition of transformations, describe the relationship between the figures. Well, Helena was the only one, and was enlarged by a scale factor of 2. You could have also said that it was twice as big. Let's go ahead and look at example 1. What is the graph of the image of the reflection across the line x equals -3 and a dilation of 0.5? So 0.5 is the same thing as half. So remember that when we do a composition, we have to do this one first and this one second. So first we need to dilate it by 0.5. We don't have a point of dilation or center of dilation, so we assume it to be the origin. And that means that I can just cut each of those pieces in half. So if I have A, B, and C, A being 2, 4, B is -2, 8, and C is 0, 10, we can create A prime being 1, 2, and B prime being -1, 4, and C prime being 0, 5. So we're getting half as big, so each of those was divided by 2 or multiplied by 1/2. So the first thing we did was move that shape to 1, 2, -1, 4, and 0, 5. So now our shape has been reduced by half. This is A prime. This is C prime. This is B prime. Now we need to reflect across the line x equals -3. So x equals -3 is this vertical line right here. And remember, we can just move these points directly across, or we can, so we're switching it from here to here. So it's 2 on that side, so it will be 2 over here, or B prime. And then we come to A, and instead of being 1, 2, 3, 4, 1, 2, 3, 4, we'll move it over here. And C was 1, 2, 3, 1, 2, 3. And this is a double prime because it's the second one. So A double prime is at -7, 2. And B double prime is at -5, 4. And C double prime is at -6, 5. Go ahead and pause the video and do the try-its on your own. Thank you for pausing your video and doing the try-it. On try-it A, remember to do the translation. First, we were moving it 1 right and 2 down. So our new points were here. So it moved from the blue to the green. And then we multiplied each of those new ones times 2 to get the final x double prime, y double prime, and z double prime. And on B, we needed to rotate 90 degrees first. And that was using that rule for 90 degrees counterclockwise. We always assume it's counterclockwise unless we're told to go clockwise. And that means that xy changes to -yx. So we moved from there from the green to the blue. That was a rotation of 90 degrees counterclockwise, and then a dilation of 3. We multiplied each of those times 3 to get those new points. So we first rotated it 90 degrees, and then we enlarged it by 3.